Hey guys, today we are going to discuss the theorems in the lesson circles. Okay, there are a lot of theorems in the lesson circles. So the first three theorems are the easiest theorems. So now we are going to discuss every theorem in brief. So the first theorem states that equal chords of a circle. Equal chords of a circle. First we need to know what are the chords. Here you can see AB and CD which attaches to the two sides of a circle. Okay. On the remaining part of the circle they are attached to two. Okay. So these are chords like AB and CD. Equal chords. They are saying that AB is equals to CD of a circle subtend or gives equal angles at the center. See, you can see AOB, COD. They are asking to prove that this angle and this angle are equal. What did they say? We learnt in the triangles chapter how to prove the congruency part, right? So what are given here? Or the proof we can write. What are given? OA is equals to OD. This is from the triangle AOB and COD. OA is equals to OD because it is a radii. Radius of a circle are equal, right? So after completing this, we have OB is equals to OC. Why? This also radii only. So what did they say more? That the chords are equal. What are the remaining parts of a triangle AB and CD? What did they say? AB is equal to CD because chords, and also it is given. So what can we say about all this? That triangle AOB and triangle COD are congruent. Triangle AOB and triangle COD are congruent. If they are congruent, we can say that angle AOB is equals to angle COD by CPCT, right? By CPCT, we can prove that this and this angles are equal. So what else did they ask? Subtend equal angles at the center. Equal angles at the center, we proved they are equal. So this is the theorem 1. So theorem 2 is exactly opposite to theorem 1. Okay, we will do theorem 2 now. So in theorem 2, what are they saying? If the angle subtended by the chords, angle subtended by the chords, what are the angles subtended by the chords? These are the angles subtended by the chords. So they're saying that angles subtended by the chords of a circle at the center are equal. They're saying that these two angles are equal. And they're asking us to prove the chords are equal. We need to prove that the chords are equal. So what is given? The proof OA is equals to OD. We already know this. OC is equals to OB. We already know this. We saw it in the first theorem, right? The only thing you need to change is AB is equal to CD. We proved there. We need to prove that we proved like that. So we need to prove the chords are equal here, not the angles. We need to prove that the chords are equal. So finding the chords, then what else is given? Angle AOB is equals to angle COD. Okay. So now these three are equal. So by what it is equal? By SAS congruency, these are equal. After saying that these two triangles are congruent, what else can we say? The chords are also equal by CPCT. So this is about the two theorems we have in the lesson. So in theorem 3, what did they give? The perpendicular from the center of the circle. Here what is the perpendicular from the center of the circle? From the center. What is the perpendicular? OC is the perpendicular. Okay. From the center of the circle to the chord. What is the chord given here? AB. We already learned about the chord. Okay, right? AB bisects the chord. So what we need to prove here? What is the RTP required to prove? That AC is equals to CB. We need to prove that this and is equals to this. That means that if it bisects that only, we can say that AC is equals to CB, right? If we prove that this and this parts are equal, then we can say that OC bisects AB. So we can draw the construction here. OA to O to B, right? What is OA and OB? They are radii, yes. They are the radii. So we can say that OA is a radii and OB is a radii, and we can say that this equal to this. Okay. So what is proof here? What is required to prove? AC is equal to CD or OC bisects AB. So what is the proof here? From triangle OCA and triangle OCB. OA is equal to OB, right? OA is equal to OB. Why? Radii. Okay, one part is proved. Here in two triangles, what is common here? What is common? OC is common. Okay, OC is equal to CO. Common side. Okay, then what else is given here? Okay, which side we can't find side or angle. So again we will read the theorem. The perpendicular. What is meaning of perpendicular from the center? That it forms 90 degrees here. It forms 90 degrees. So what can we say? Angle OCA is equal to angle OCB is equal to 90 degrees. That is perpendicular. It is perpendicular from the center. So what can we say about these two triangles? Triangles OCA is congruent to triangle OCB. By what? It is 90 degrees at C. Okay. The hypotenuse is equal. That means hypotenuse for this is what? Here right angle means the opposite to it. OA is the hypotenuse. OB is the hypotenuse. The hypotenuse are equal and it forms 90 degrees, means we can say that triangle OCA is congruent to triangle OCB by RHS congruency. By saying that these two triangles are congruent, what else can we say? We can say that AC is equal to CB by CPCT. Hence we proved that the chord bisects. It bisects the OC from the center. It bisects the chord. So the theorem 3 is also proved. So here is theorem 4. Okay, this is theorem 4. This is a bit easy theorem if you understand this. Okay, what is the theorem? Chords equidistant. What are the chords equidistant from the center? OP, OQ. Okay, this is the chord which bisects. AB and CD are the two chords given in the picture. You can see AB, CD are the two chords equidistant from the center of the circle, are equal in length. What we need to prove here? What we need to prove? RTP, that AB is equal to CD, right? So here the dotted lines what I kept, okay, the jagged lines what I kept here is the construction what we did. The real figure is the ones which with the straight line. Okay, what constructions we did? Everything is radii what we have constructed. Okay, OA, OC, OD, OB are radii we constructed in the figure. So what is the proof we need to prove? Okay, first we are taking one triangle. We need to take two triangles in the question given. Okay, what is the first triangle we are taking here? Anything you can take from triangle AOP and triangle, okay, QOC. These two triangles we took. This is the first triangles we are taking. Okay, triangle AOP and triangle COQ. These are the two triangles we are going to take. So from the first triangle, what can you take common? Okay, the things you can take are the OA is equals to OC, because they are radii. We know that the radii of a circle are equal in length. Then what we can prove? They said that chords equidistant from the center of the circle. Okay, what is here? OP is equal to OQ. We got it in given only. OP is equals to OQ. They gave it in given only. Given. OP is equals to OQ. And what else we have here? 90 degrees. Okay, we have 90 degrees there. We draw perpendicular. The diagram shows that it is 90 degrees here. What can we say? OPA. is equal to angle OQC, 90 degrees. So by proving this, we can say that triangle AOP congruent to triangle QOC. By what, children? So here we have 90 degrees. Okay, we have 90 degrees and the hypotenuse is equal. When it is 90 degrees and the hypotenuse is equal, then it is what? RHS property. By RHS property, we proved that triangle AOP is congruent to triangle QOC. After proving, what can we say? AP is equal to QC by CPCT. Okay, take it as 1. Okay, take it as 1. AP is equal to QC. This is important, so I am writing it again. AP is equals to QC. So the next two triangles what we are going to take is from triangle POB and triangle QOD. We are taking these two triangles now. Okay, can you see the two triangles we are taking? What else can we take here? OB is equal to OD because they are radii. They are radii. Okay, after taking the radii, and what else is there? OP is equals to OQ. OP is equals to OQ. We already know that. That is already given. We used it in the first triangle also. What else is there? The 90 degrees. OPB is equal to angle OQD, that is equal to 90 degrees. So after knowing that the hypotenuse is equal and it is 90 degrees, means we can say that triangle POB is congruent to triangle QOC by RHS congruency. After proving that these two triangles are equal, what can we say? We can say that PB is equal to QD. Take it as 2. This is equation 1, this is equation 2. From equation 1 and equation 2, we need to add them. Add equation 1 and 2. What is there? AP. AP is equal to QC. Here what is there? Plus PB plus QD. Okay. After adding this AP plus PB, what did you get? It's AB. After adding QC plus QD, what did you get? It's CD. So therefore, the chords equidistant from the center of the circle are equal in length. That is, AB is equal to CD. Hence, we proved the fourth theorem also. So here you can see the angle subtended theorem, which is an important theorem which we will get in exams. Like this is the most important theorem. You can get bits also. So I will explain this theorem first briefly. You should understand what is this theorem, why are we proving it, right? So here, according to this theorem, just this is a rough figure. So here, if it is 10 degrees, think if it is 10 degrees here, it will be double. Down this triangle is there, no? The angle will be 20 degrees. Suppose here it is 20 degrees, here it will be 40. What did you understand? That this is double than this. So how to prove that? This is the theorem. If you get it as bits, you should remember that this will be double of this. Okay? So for finding what, first read the theorem. The angle subtended by an arc. The angle subtended by an arc. As we have discussed earlier, the angle subtended by an arc. Angle subtended by an arc at the center. So this is the angle we are talking about. At the center is double the angle subtended by it. Suppose this is the circle. The angle can be like this also. Not only like this, according to the figure, the angle subtended by an arc at the center is double the angle subtended at any point on the remaining part of the circle. On the remaining part of the circle, rather than this, it can form like this also, it can form like this also, it can form like this also. There are so many ways for the finding because they said that subtended at any remaining part of the circle. at the remaining part of the circle, it can form anywhere. For example, we have taken it formed here. Okay. So first, what is given? O is the center of the circle. They said that the O is the center of the circle and AB is the chord. So what we have discussed, C is any point on the remaining part of the circle. Okay. So what we need to prove? RTP. It is more important that angle AOB. Angle AOB is equal to 2 of angle ACB. As we have discussed, it is double. This is double the angle subtended at the remaining part of the circle. So construction, what did we draw the construction? The dotted line here. You can see, I guess. The CP. CP is the construction. You can see the jagged line. That is the construction. We draw away CP, which passes through the center O. It passes, they are saying that it passes through the center O. Okay. So the proof we have is OP, the OP ray divides the circle, divides the quadrilateral AOB into two triangles. Here you can see AOC. This is one triangle and PCB is another triangle, triangle 2. This is one triangle, this is one triangle. We divided it into two triangles. Okay. So we know that AC is equal to the OA is equal to OB. After knowing that this and this sides are equal, what can we say? OAB or OAC. OAC, where is it? OAC. This is equal to this. We can name it as X. OCB. See here, we named it as X and X. Okay. From triangle BOC. BOC. This is X, then this is X. From triangle BOC, we are naming it as Y. So I am writing here, you can see. In triangle AOC, we are naming angle OCA is equal to angle OAC is equal to X. We named it as X. And we named angle OBC is equal to angle OCB. We named it as Y. Why we are naming that these two are equal? We are saying that these two are equal because the angles opposite to equal sides are equal. The angles which are opposite to equal sides are equal. Suppose you have a triangle. This side ABC, you guess, AB is equal to AC means this will be equal to this. According to this theorem, we are proving that this angle is equal to this angle. Okay? We know that the exterior angle sum. We know that the exterior is equal to sum of two opposite interior angle. As we have learned in the lower grades, that exterior angle, this exterior angle, just example here I am giving, this exterior angle, this two of interior angles will be equal to exterior angle. Okay. So we know that exterior angle is equals to sum of two interior angles that we are going to implement here. So angle AOP, we took 2x, right? Angle AOP is equal to angle AOAC plus angle OCA, that is equal to x plus x, that is 2x. Take this as equation 1. We are taking this as equation 1. Now we need to take from the triangle BOC. Angle BOP is equal to OBC plus angle OCB. That is y plus y is equal to 2y. We are taking it as 2. So we need to add equation 1 and 2. As we have seen the equation 1 and 2, what are the equations 1 and 2? angle AOP plus angle BOP. In equation 2 we have angle BOP. 2x from the RHS side, right hand side, what we have 2x plus 2y. This angle AOP, this angle and this angle is equal to what? Angle AOB. Angle AOB is equal to, if we take common here, what we will get? 2 of angle x plus y. So what is x and what is y? We are implementing that in their places. 2 of angle OCA plus angle OCB. Angle AOB is equal to 2 of angle ACB. Hence we proved that this angle is twice that angle. So the angle subtended theorem is clear. See, here we have the angle subtended theorem is done. So we are getting into the next theorem, that is angles on the same segment of a circle are equal. Angles on the same segment. What is a segment? Which connects to the two ends of a circle are equal. See, they are asking us to prove this is equal to this. They are asking us to prove this equal to this. First, what information we have? O is the center of the circle. C and D are the points on circumference of a circle. What is circumference? Nothing but perimeter. Perimeter of a circle, that is, we call it perimeter for the solid figures like rectangle or square, and we call it circumference for the circle. Right? So they are asking us to prove RTP. ACB is equal to angle ADB. What is ACB here? ACB is equal to angle ADB. Okay? Proof. Here angle AOB is the center of the circle. Right? So according to the angle subtended theorem, what can we say? That this is double. What can we say? That angle C is 1 by half of angle AOB. Right? Angle AOB is equals to half of angle C according to angle subtended theorem. Okay? By this we got this. This take it as 1. Angle AOB is equal to 2 of angle ADB. The same theorem applies for this also. If this is half of this, this also will be half of this. Take it as 2. Okay? 2 of angle ACB is equal to 2 of angle ADB. From this and this we got this. If angle AOB is equal to this, angle AOB is equal to this means this is also equal to this. From 1 and 2 we got this. 2 of angle ACB, 2 of angle ACB. We can cancel this out, right? If it goes here, multiplication, division, 2 and 2 cancel. So we can cancel this out. We cancel. So what did we get? ACB is equal to ADB. ACB is equal to ADB. This is what we need to prove. Angles on the same segment are equal. We proved. How we proved? According to angle subtended theorem, this will be more than this. That means double of this. So this is double of this and this also double of this. Because the D and C are lying on the circumference of a circle, on the remaining part of the circle. So we can say this is half of this. By proving this, this is equal to this is equal to this. So what can we say? That this both are also equal from equation 1 and 2. We proved that angles on the same segment of a circle are equal. So here we also have a small topic. Actually it is not the theorem, but we are explaining here the cyclic quadrilateral. The cyclic quadrilateral, it is so easy, guys. So what is there here is a cyclic quadrilateral is a quadrilateral formed in the circle. It should touch the vertices. The vertices of that quadrilateral should touch the circle. Here it touched, here it touched, here it touched, here it touched. So we are attaching those, so it forms a quadrilateral. It forms a quadrilateral, like that we are attaching. Okay, if it touches the vertices, if the vertices touch the circumference of a circle, then it is a cyclic quadrilateral. What is a cyclic quadrilateral? The specialty of the cyclic quadrilaterals is the opposite angle. Opposite angles sum will be 180 degrees. That means angle A plus angle D is equal to 180 degrees. Angle C plus angle B is equal to 180 degrees, which will be used in solving the questions or anything else. So this is simple, guys. So if it touches the vertices, the vertices touch the circumference of a circle, then it is a cyclic quadrilateral. The specialty is the opposite angle sum will be 180 degrees. Remember this. And we also have the angle formed on the semicircle. What is a semicircle? This is a semicircle. Think one triangle is there. Okay. So the angles of semicircle is 90 degrees. So here you can see, guys, it is 90 degrees. The angle formed here is 90 degrees. If the other part of the circle is there, think this is also there, the other part of the circle, and it forms a quadrilateral. What can we say here? 90. Here also angles on. That means it forms a cyclic quadrilateral if we extend it. Normally the angle of a semicircle is 90 degrees, which will be used in solving some questions or anything else. That's it, guys. These are the theorems and the important topics which will be covered in the examination point of view. So thank you. If you understand the concept, please like, share and subscribe the channel.